So, if you remember right back to the last class we had before we went to remote learning, I was talking to you roughly about why we actually did all of what we did in chapter 7. And we do it because we are going to represent quadratic equations on a graph. Okay, and when we represent quadratic equations on a graph, we generally get a graph that looks like that. We could get a graph that is inverted like that. Okay, so it's a curved graph, an archway or a U shape. So if we wanted to put, and I'm just going to go through and do this example, then I'll explain it a little bit more fully. If we want to plot this on a graph, we want to find the x-intercepts and the y-intercept. So let's find the y-intercept. The y-intercept is when x equals 0. So y equals 0 squared plus 0 minus 8, which is minus 8. Okay, so that's the y-intercept. That is where this graph cuts the y-axis. Right there, minus 8. The y-axis, y-intercept. Okay. If you want to work out the x-intercepts, this is exactly the same as if we're doing linear graphs. So the x-intercept is when y equals 0. So we're going to go 0 equals x squared plus 2x minus 8, and hence why we need to solve equations. So we're going to find when this equation equals 0, and we need to factorise it to do that. So this one we're going to do with flag and cross, x times x on that side. We need a negative 8, so we need a 4 and a 2. One has to be positive, one negative. We want a plus there, so we go plus on the big number, minus on the little. 4x minus 2x gives us, so plus 4x minus 2x gives us a plus 2x. So we're happy with that. So there we go 0 equals x plus 4 bracket x minus 2. So we've factorised that expression to get this. So that means this has to be either 0, so x equals negative 4. Negative 4 plus 4 is 0. Or this has to be 0. So for this to be 0, x has to equal 2. 2 minus 2 is 0. So there are two x-intercepts. So x-intercepts at minus 4 and at 2. Okay, so this is our graph. We know our graph's going to look something like that. We know it's going to be a U shape because it's got a positive x squared. So our graph is going to basically be a curve. It's going to come down, and I'm going to have a go at it. Now the minimum is going to be halfway between these, so it's going to come down to about here, somewhere down there, and curve back up. So I'm going to cheat. I'm just going to work it up like that, and I missed. That should go through that point. And it's a pretty ordinary curve. We want to get a nice smooth curve if we can. That's part of the skill. That's what our graph looks like, roughly, except for all that rubbish there. Okay, so if we want to do this one, y-intercept is minus 2. Okay, so I'm just going to draw my axes here. And over there we've got that line, go back to the pen. So the y-intercept is at minus 2. That's the y-intercept. We don't have to do anything, it's just a number that's on its own. Okay, notice back here, the y-intercept is minus 8, it's just a number that's on its own. We don't have to actually do this calculation. So the x-intercept is when y equals 0, so 0 equals x squared plus x minus 2. We have a go at flag and cross, x times x, we want 2 times 1, so 2 times 1 has to be positive, 1 negative, so positive and negative gives us a positive there, so plus 2x minus 1x is plus 1x. So we've got 0 equals x plus 2, x minus 1. So here, x equals minus 2, it's always going to be the opposite sign, or x equals 1. Minus 2 plus 2 is 0, so that equals 0. 1 minus 1 is 0, so that equals 0. So there are two solutions. X equals 1 and x equals minus 2, and we've got a graph that comes down and looks something like that. It should be a smooth curve. My curves today are not working. It should look something like that. Okay, I'm trying to get to the points. If you've got a mathemat, that's got a parabola on it. You could use that. Okay, that's what we're doing. So we'll have a look at this one. Let's quickly just draw our axes. And back to the pen. So, y-intercept is minus 5. So down here at minus 5, put numbers on your axes before. I'm just taking shortcuts here, but put my numbers on your axes before. So minus 5, go through at minus 5. So we're going to go for the x-intercept, 0 equals 2x squared plus 4x minus 5. And we could try flag and cross. It's not going to work. Okay, flag and cross is not going to work. This is not going to have whole number solutions. Okay. But you'd need to actually try it to find out that it's not going to work. Okay, I'm taking a shortcut here. So normally you just try flag and cross, see if it works. If it doesn't work, we use the quadratic formula. So a equals 2, b equals 4, c equals negative 5. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Let's go up and work this bit out. We got 16, 4 times 2 is 8. Sorry, negative 4 times 2 is negative 8. Negative 8 times negative 5 is plus 40. Let's just check that. So 4 times 2 is 8. 8 times negative 5 is, yep, so 16 plus 40, which is 56. So we've got x equals negative 4 plus or minus the square root of 56. That's always best to do that first. So you just got a number here over 4. So x equals negative 4 plus the square root of 56 over 4. Or x equals negative 4 minus the square root of 56 over 4, and we're at calculator time. So negative 4 plus the square root of 56. Don't forget your brackets around the top bit, or hit equals before you do divided by 4, and we get 0.87. Make sure, just do that in your calculator right now to make sure you can get that. So 0.87, and the other one, negative 4 minus square root of 56. So either have your brackets around it or hit equals now, then divided by 4, and we get negative 2.87. So we've got about 0.9 and negative 2.9. So we're going to go negative 0.9, negative 2.9, and we've got a what have I done wrong? Could be an error there, but we've got a graph basically that looks like that. I'm not sure if my signs are right. Oh, that's fine. Yeah. They have an error in the book actually, example 7b. So that's what it looks like. Okay, so that's all we're doing. So we can either use flag and cross. Well, flag and cross will work sometimes to get our solutions nice and easy. If flag and cross doesn't work, we have to use the quadratic formula, which we used in 8.2, in 8.3. Okay, So, sometimes, most of the time there are two solutions, but sometimes there is only one solution. So if we have something like y equals x minus 2 squared, then that's y equals 0 equals x minus 2, and both of these, x equals 2 and they've got the same solution. So we end up getting a graph that looks like that. It just touches at x equals 2. So there's only one solution. So that's what the graph would look like. Okay. Sometimes also though, we can get a graph that doesn't touch at all. So we might get a graph that comes down and only has a y-intercept. Okay, because the graph's being pushed up and it doesn't cross the x-axis. So in that case, there are no solutions. We're going to talk about that more in the next chapter. At the moment, you only really need to be aware there are some cases where there are no solutions. There are some cases where there can just be one solution. We'll explain that more in the next chapter as to why that happens. Now there's a little bit on confirming solutions. Confirming solutions is just substitution. Now I'll give you the solution and you have to substitute in. So if you have a look at worked example 8, they tell you that x equals 1 and x equals negative 2. You just have to substitute it in. So we've got x squared plus x minus 2 equals 0, and we're telling you that x equals 1 is a solution. So we just go 1 squared plus 1 minus 2 equals 0. 1 plus 1 is 2, minus 2, we get 0 equals 0. Yep, that solution is confirmed. Okay, that's all confirming solutions is. And there's one more real life type example. There's a graph given to you in worked example 9, it's on page 312 of your book, of a person hitting a golf ball, and the height of the golf ball, h, is given by this formula. Now they actually show you the graph of the golf ball, so it's a curve that looks like that. And it's h is 0 at 0, but x equals 0 and x equals 180. So x is how far it's travelled along the ground. Okay, and the reason for that, if we factorise this expression, take the x outside the brackets, we get these two numbers multiplied together. If we make that 0, x either has to be 0 or x has to be 180. Okay? We have to have a 0 there to get a 0 answer, or we have to have this bracket of 0 to get a 0 answer. So how far did the person hit the golf ball, or how far did the golf ball land from the golfer? Well, it's landed over here at 180. So it started off, the golfer hit it when x equals 0. It was back at ground level at x equals 180, h equals 0. So the golf ball was hit 180 metres. That example is on page 312. Just have a quick look at it and a read through it. Then I want you to go and work through exercise 8.4. Most of these you're actually given the graphs and you're just reading from the graphs. Okay, so you're reading the solutions from the graphs. So if we were doing that and we went back and had a look at this, we're reading a solution from the graph. X equals minus 2 and x equals 1. That's all we have to do. Okay. Okay. So all the best with that. I'm on Teams chat if you need help. Make sure you're asking for help, and I'll catch you in the next class.